we're all rolling.
So is this self-powered? Does this have any power inside it to run the micro that's in there or the disk drive?
No. What it's doing is it's making these AC motors run at absolute 100% efficiency. No 99.999.
I know, but normally that would still take more power than even at 100% efficiency.
I can't tell the secret to this stuff.
These are only about 82 to 83% efficient.
Oh, they're not. They're probably not better. Maybe 12 in reality.
No,
You think they are?
I got the specs on it. Can I see it?
Oh, okay. Well, I've always read that in the past, and I mean, gosh, when you know the double E's would come along and do the actual load calcs, you know, on automation. I used to be a control tech at Dow Chemical, and I was a lead man. And all we did was controls. I mean, massive controls. And they'd come along and they'd be talking, damn, another 12%er, another 13%er. And these were motors, I mean, 50 horsepower motors bigger than this truck. And I mean, gigantic. I'm going, how big is a 200 horse? And they showed them to me. But these were made in 1942.
Oh, yeah. Well,
now, they're not that big today, but yeah.
But today we don't make any motors under 80. You know, and motors that are 7.5 to 15 horse, they're about 87, 88.
80% efficient, yeah.
Production motors.
Well, I'm making them 100%.
But he was just saying, talking about the power factor, is that we really can't take the voltage and the amperage and get a real output wattage without knowing the power factor.
Well, you can go with one. I mean, one's standard.
I know. Can't be one. Look at the inductance here.
I know.
No, it can't be. I mean, if it was.
So what would you say it was?
I'd say probably between 70 and 75%. 0.7, 0.75. Somewhere in that area.
A power factor?
Power factor, yeah.
Okay. Well, then we'll call it that.
Because you don't have any capacitors. Unless there's capacitors in here, it's all inductive.
Yeah. All right, we'll go with the 7.5. That's a lot better.
No, I'm just saying.
It's a lot better than 1.5.
Yeah. No, it's not. Without any capacitors in there, it's not over the line.
So Pete, could you point out that your controller unit is right there? First off, this is Pete's Sumaruck.
Sumaruck, right.
Sumaruck is your last name. And this is your device, which takes a very low current input and delivers a very high current capability output.
Right.
So if you can give the basics of
the
voltage in and voltage output.
It has single phase input power, 60 cycle, 240 volt. It's milliamps, like a quarter of a milliamp input on two, I believe they're 44 gauge toy airplane wires is what the input is. The output is running 5 3-phase AC motors with number, I believe it's number 12, it might be 10, but I think it's number 12 stranded SJO cord. and they're pulling 16.7 or 16.6 amps output. And what it's doing is it's making the motors run at absolute efficiency. I mean, that's as layman as I know how to put it. I mean, there's a guy here, I think he's a little smarter than I am, is calling it something else, but it's really, really good. These motors are actually running for absolute zero cost in electricity. It's not costing, if I had them plugged into the wall, which we can do, it would do nothing to my electric bill. I could leave them hooked up for 30 days. It would do nothing to the electric bill. Nothing. Matter of fact, the meter, I still have one of the old-timey meters with a little round aluminum wheel. It wouldn't, the speed if we turned everything off in the house and only had the motors running, the wheel would never move because the meter won't read milliamps. It won't do that. I don't think any of that. Do you know if the digital ones, the new ones, they read milliamps? I don't think they do.
They're not quite that sensitive, but it will integrate over time. I mean, ultimately, it'll indicate something over the course of a year or something. But,
yeah.
You know, if you're only drawing a fraction of a watt input power,
it's not going to do anything, yeah. But it's a really neat device. It's this is going to bring about generator systems for homes and commercial, industrial installations where you're basically not going to need the power company.
Well, this is certainly the highest efficiency demonstration of an electric motor I've ever seen myself. We have Jim Dunn here. Have Jim Dunn here from New Energy Congress. Do you have any comments you want to add here?
Well, this is definitely a major breakthrough, and we're not sure exactly what Peter's done here, but we've all witnessed 5 AC motors running without any real load on them, but running each drawing, a couple amps of current and totaling as much as 16 amps off maybe a fraction of a watt of input into his controller. So we're all baffled about are there more than 100 mice on the little wheels inside there?
Two fat squirrels.
Two big fat squirrels.
Well, what we need to stress here is we're not seeing any load on the motors, but the motors do have to run in sync. So the load that we're seeing on the unit today are the motors themselves just spinning, which is substantial.
Right.
And my screensaver. Okay. Sterling, you have a couple of words you might add over here?
Sure.
Yeah, this is Sterling Allen, also from New Energy Congress.
Jim's going to be the more authoritarian on what's going on here, but to put it simply, you have the input wattage, which is very low. It's I think 0.05 watts going in, and then you have 4,000 watts going out. If you do the math on that, we calculated 70,000 COP. Of course, that's not taking into account reactive power and things like that. That's just straight
there's no power
watts
factor in there, but it's still significant.
Yeah.
Still significant.
So obviously there's something very worth pursuing here that could revolutionize our entire infrastructure, modern society, electrically.
It's very impressive, to say the least.
We're just going to get a bite to eat. We'll be back in a few minutes.
Okay. That's cool. Our other visiting expert back there, Dr. Greer. Okay.
We'll be back in a minute.
All right, we're going to wrap up here. This is Ken Rasmussen from CommuteFaster.com Energy Page, and we're signing off from today's report on November 24th, Monday, 2008.